Hello guys, welcome back to Java Python Interview Hub. In today's video, we will cover top 65 SQL interview questions and answer that will definitely boost your confidence and you will definitely crack the interviews. In this particular video, we will cover SQL queries and procedures, triggers and cursors, and real world solutions. Step by step explanation with sample table and practical example. So it is perfect for campus placement and entry level position. Build confidence with fundamental concept and common interview scenarios. For the experienced professional, I have covered advanced topic for IT jobs, senior developer roles, and database administrator position. Tackle complex scenarios with ease. For the specialized questions for data analysis, reporting, and business intelligence position, master data manipulations and insights. So, without wasting a time, let's start the top 65 SQL interview question. You can see here one sample database schema is there. We will create a small HR plus sales database with 4 interconnected tables. So it will demonstrate real world SQL scenarios. The first table is employee table, in which we have employee ID, name, department ID, salary, hire date, and manager ID. Next is we have a department table. In that, department ID, department name, and location. So notice that how the department ID in the employee table creates a foreign key relationship with the department's table, enabling powerful join operation in SQL queries. So our third table is project. In that table, we have project ID, project name, department ID, start date, and end date. This project example demonstrate common business scenarios you will encounter in SQL interviews, from date range queries to cross department analysis. And our fourth table is employee underscore project, the junction table that connects employees to their project assignments, tracking roles, and time investment. So now the database foundation is complete. Now you are ready to tackle complex SQL queries using these interconnected tables. The next session will cover all 65 questions with detailed solution. But I will recommend you to all to create this table in your IDs in your database, and then after perform queries given by in this video, I will assure you will definitely master SQL queries with basics to advanced. So, a comprehensive guide to essential database queries from basics to advanced levels. Master the fundamental SQL operations that every developer needs to know, with practical examples using employee and project management database. So, first of all, our first query is select all employees. The most fundamental SQL operation retrieving all data from a table. The query will be what? Select star from employees. Use the wildcard star to select all columns from the employee table. What it does actually, it will return every row and every column from the employees table. While useful for exploration, avoid select star in production code. Specify exact columns needed for better performance and clarity. So this is your starting point for any database exploration. See what data you are working with before crafting more specific queries. So let's move to the next query. Find IT department employees. Combining subqueries to filter employees by department name rather than ID. So our query will be select EMP underscore name from employee, where department underscore ID is equal to into bracket yani subquery. Select department ID from departments where department ID is equal to IT. So inner query finds department ID for IT. Outer query uses that ID to filter employees. Returns only employee names from IT department. So this pattern is essential when you know descriptive values like department names, but need to filter by foreign keys. Next query is sort employees by salary. So it is very simple, like select EMP underscore name, salary from employees, order by salary, desk. Desk means it will give your data in a descending order, right? So quickly identify highest paid employees, useful for salary analysis and budgeting decisions. Next is calculate average salary. So using aggregate functions to derive meaningful statistics from your data. So query is the AVG function. Select AVG into bracket salary as AVG underscore salary from employee. So it will calculate the arithmetic mean of all salary values. As AVG underscore salary creates a readable column name, makes results more professional and understandable. So in business intelligence, essential for salary benchmarking and budget planning, foundation for more complex analytics. So there are other aggregate functions are there. Instead of AVG, you can use mean, max, sum, count. Aggregate functions ignore null values automatically. So you don't need to filter them out explicitly in most cases. Let's move to the next query. Filter by hire date. So using date comparisons to find employees hired after a specific time period. So your query will be select EMP underscore name from employees where hire date greater than particular date. So date format standards are ISO format, YY, DD. Works across all major databases. Avoids ambiguity in date interpretation. Common date operators are greater than, less than, equal to and between. Track recent hires for onboarding programs, analyzing, hiring or identify probationary employees. But be careful with time zones. When working with date time fields, consider using date functions to extract just the date portion if needed. So next is count employees by department. So grouping data to understand distribution patterns across organizational unit. The query will be select department ID, count star as employee underscore count. From employees, group by department ID. So you can see on your screen, if the department ID is 1, employee count is 12, then 2, then 8, 3, then 15, 4, then 6, right? So it will give the employee count for a particular department ID. The query forms the foundation for organizational analysis and resource planning decision. Maximum salary in finance. So combining aggregate functions with the specific filtering condition, select max of salary from employees where department ID is equal to 2. This is the basic query. But if you want advanced version, then select max of salary as max underscore finance underscore salary, count star as finance employees from employee where department ID is equal to 2. So pro tip, combine with employee name to find who earns the maximum. Select EMP underscore name, salary from employees where department ID is equal to 2, ordered by salary, desk limit 1. Right? So let's move to the next query. Get distinct job roles. Query will be select distinct role from employee underscore project. Why use distinct? Without distinct, you would see repeated role names for each employee assignment. Distinct gives you a clean, unique list, right? Distinct works on the entire row. when selecting multiple columns, not just individual columns. Let's move to the next. So find employees without manager. So query will be select emp underscore name from employees where manager underscore id is null. So please note down important null concepts. Use is null, not is equal to null. Null represents missing or unknown data. Null is not the same as empty string or zero. Use is not null for opposite condition. Null handling is crucial for data integrity and accurate reporting in any database system. Most organizations have 1 to 3 employees without managers at the executive level. So if you see many employees without managers, it might indicate data quality issues or incomplete organizational setup. Let's move to the next. Find names starting with J. So using pattern matching with wildcards to filter text data based on specific criteria. The query will be select emp underscore name from employees where emp underscore name like into single quotation J and the percentage. So it will give you the name where emp name is starting from the J. The number of characters list will be anything. Other wildcard examples will be percentage son, so ends with son, percentage John and percentage contains John in between the names, J underscore N, J plus any single character plus N, right? So pattern matching is essential for search functionality, data validation and flexible filtering in the application. The like operator with wildcards is your gateway to flexible text searching and pattern recognition in SQL database. Let's move to the next. Employee department join. Right. So combining related tables to create meaningful, readable reports with descriptive information. The query will be select e.emp underscore name, d.dpt underscore name from employees E, join departments D on e.department id is equal to d.department id. This is called the equi-join. So key components are what? Table alias is E for employee, D for department. On close specifies how tables relates and the choose specific columns from each table. Join types are inner join, left join and right join. So sample output will be there. Joins transform cryptic foreign key numbers into human readable information, making reports much more valuable. Let's move to the next query. Multi-project employees. Using group by and having to find employees working on multiple projects simultaneously. The query will be select emp underscore id from employee underscore project. Group by employee underscore id. Having count project id is greater than 1. So it will give the data where project id is greater than 1 and give the employees. So where versus having, this is the most important interview questions again. Where filters individual row before grouping, while having filters groups after aggregation. So having is essential when you need to filter based on aggregate calculation. It's the where clause for grouped data. Consider joining with employees table to get names instead of just IDs for more readable results. Let's move to the next. Total hours by the employee. So again, aggregating time data to understand individual workload and project commitment levels. The query is select employee underscore ID, sum of hours underscore worked as total hours from employee underscore project group by employee ID. So it will give you a total hours of a particular employee by employee ID. You can use also enhanced version in your screen. So you can execute both queries in your IDs and get the best result right? And please, after executing queries in your particular PC, laptop, please comment in the below section to your output. So the data is crucial for project billing, resource planning, and identifying potential burnout risk. Next is salary range filtering. So using between operator to find employees within specific compensation brackets. The query is select EMP underscore name from employees where salary between 60,000 and 70,000. So between characteristics inclusive includes both boundary values 60,000 and 70,000. Means greater than or equal to 60,000 and salary less than or equal to 70,000. You can use different options. You can see on your screen. Next is unassigned employees. So using left join to identify employees not currently assigned to any projects. This is one of the most important query. So select E underscore EMP name from employee E, left join employee project EP. Here E and EP is what? Your alias, your objects. On E dot EMP underscore ID is equal to EP dot EMP underscore ID. So we have a common column where EP dot project ID is null, the most important condition. So left join ensures all employees are included. Unassigned employees will have null in project fields. Where close filter to show only null matches. Result shows employee available for new projects. So mastering left joins with null checks is essential for finding gaps in your data, relationships, and ensuring complete resource visibility. Now we will move to the intermediate level SQL queries. So master complex database operations with advanced SQL techniques for real world scenarios. Question number 16 to 35. So your first advanced query is, intermediate query is, get highest salary per department, right? So select department ID, comma max of salary from employees, group by department underscore ID. The query uses the group by clause to organize employees by department. Then applies the max aggregate function to find the highest salary within each group. This is essential for understanding compensation distribution across organizational units. The group by clause is fundamental for department analysis and reporting in HR system. Next is find employees who earn more than their manager, right? Surprise. Select E.emp underscore name from employees E. Join employees M. So here E and M both are object alias of employees table. On E.manager ID is equal to M.emp ID where E.salary greater than M.salary. This query demonstrates a self-join technique where the employees table is joined with itself. The alias E represents employees while M represents managers. This pattern is crucial for hierarchical data analysis. Self-joins unlock powerful analytical capabilities when working with hierarchical organizational structure. Next is list projects with more than 160 total hours. So select P.project underscore name from projects P. Join employee underscore project EP on P.project ID is equal to EP.project ID group by P.project name having sum of EP.hours work greater than 160. This query combines join operations with group by and having clauses. The having clause filters grouped results based on aggregate conditions, unlike where which filters individual rows. Next is find employees with second highest salary and this question is very, very important. So I hope you will get this query, and you can consider this is one of the most important interview question in the SQL. Let's move to the next. Get departments with no employees. So the query will be select d.dept underscore name from departments D. Left join employees E on d.department ID is equal to e.department ID, where E underscore employee ID is null. So the left join ensures all departments appear in results, even those without employees. The where E.emp ID is null. Condition identifies departments with no matching employee records. The next is get top 3 highest paid employees. This is again one of the most important query. The query will be select emp underscore name salary from employees, order by salary, desk means descending order, limit is 3 means the 3 data. So this straightforward query combines order by for sorting with limit for result restriction. The desk keyword ensures highest salaries appear first, making this an efficient solution for top n queries. Next is find projects with no employees and total salary by department. So for unassigned projects, select project underscore name from projects P, left join employee project EP on p.project ID is equal to ep.project ID, where ep.employee ID is null. And department salary totals, so select department underscore ID, sum of salary from employees, group by department ID. These complementary queries demonstrate different analytical perspective, identifying resource gap and calculating financial summaries across organizational units. Now next is find longest running project. So select project underscore name from projects, order by end date minus start date, desk limit 1. This query performs date arithmetic directly in the order by clause, calculating project duration on the fly. This approach is efficient for finding extremes in calculated values. Get employees who worked on both project 201 and 202. So for this query, select employee underscore ID from employee project, where project ID in bracket 201 202 group by employee ID having count distinct project ID is equal to 2. This query uses in clause for filtering, group by, for aggregation and having with count with distinct to ensure employees worked on exactly both specified projects. Next is list employees and number of projects they worked on. So select employee underscore ID, count project ID as project count from employee underscore project, group by employee ID. This aggregation query provides valuable insights into workload distribution and employee utilization across the organization. Next is show employees with same salary. Then query will be select salary, comma, group concat into bracket employee underscore name from employees, group by salary having count star greater than 1. Here the group underscore concat function creates comma separated list of employees name, while having count into bracket star greater than 1 ensures only duplicate salary labels are displayed. So let's move to the next query. Get employees who joined in the same year. So select your hire date as join year, group underscore concat into bracket employee name, from employees group by year into bracket hire date. This query uses the year function to extract temporal components from dates, enabling cohort analysis for HR planning and retention studies. Next is find department with maximum number of employees. So query will be select department underscore ID, comma count star as CNT from employees group by department underscore ID, order by CNT, desk limit 1. This query identifies the largest department by employee count, providing crucial insights for the organizational structure and resource allocation decision. Next is get all managers and their team size. Then select m.emp underscore name as manager, count e.emp id as team size. From employees, m left join employees e on m.emp id is equal to e.manager id. Group by m.emp underscore name. Next is list employees with no department. The query will be select emp underscore name from employees where department ID is null. Very simple. This simple but crucial query helps identify data integrity issues in the HR systems. Employees without department assignments may indicate new hires pending assignment, employees in transition, data entry errors, and contractors or temporary staff. Get employees assigned to projects that ended before 2020. So select distinct e.emp name from employees e, join employees underscore project ep on e underscore emp id is equal to ep.emp id, join projects p on ep.project id is equal to p.project id, where p dot end date less than a particular date. This 3 table join with distinct ensures each employee appears only once, regardless of how many pre-2020 projects have they worked on. Next is find department with the highest salary expense. One of the most important query. Select department ID, sum of salary as total salary from employees group by department ID, order by total salary, desk limit 1. This financial analysis query helps identify which department consumes the largest portion of the salary budget, crucial for cost management and budget planning. Next is get employees with salary in top 50%. Select emp underscore name, salary from employees where salary greater than, into subquery select percentile underscore count 0.5 within group order by salary over. This advanced query demonstrates statistical SQL functions for percentile based analysis. The percentile underscore CONT into bracket 0.5 function calculates the exact median salary, providing a more precise threshold than simple averages. Mastering percentile functions opens doors to sophisticated data analysis and reporting capabilities. Now let's move to the advanced SQL questions. Right? Ready? So master complex database queries with the real world scenarios and the detailed explanation. This collection covers advanced SQL techniques including window functions, subqueries, joins, and analytical operations. So into the first advanced query, find employees working in all project. So complete project participation analysis. For the logic breakdown, for each employee count project in their department and match with department's total project. Join employees with their projects, filter by department alignment, and compare individual versus total count. The key technique will be having with subquery. So you can see query on your screen, right? So because this query is very lengthy, so for if you write this query in your ID and will perform, you will definitely get all employees working in all projects. So next is currently running projects. This query identifies projects that are currently active by checking for null end dates or future completion dates. Pro tip: use CUR date for date only comparison or now for timestamp precision. Select project underscore name from projects where end date is null or end date greater than current date. Next is project utilization analysis, means calculate hours per day efficiency, and you can find a query on your screen. For the business value, this metric helps identify over allocated or underutilized projects for better resource planning. But please create these queries in your SQL IDE and you will get definitely your desired result as per the mention. Next is employees without manager. Select EMP underscore name from employees where manager ID is null. Very simple. This simple query reveals organizational hierarchy by finding employees at the top of the reporting structure. Next is IT only project participation. This complex query identifies employees who have exclusively worked on IT department projects, ensuring they have never participated in projects from other departments. So query is on your screen. Because this is a very lengthy query, so I'm not able to explain all the things. You will have to write these queries and definitely you will get your desired result as mentioned. Let's move to the next query, and the project timeline overlap detection, means concurrent projects analysis. So the query uses a self join with careful date logic to identify overlapping project timelines. Please be careful while writing this query, because every column and alias object name is very important, right? Key insights: the condition p1.project_id less than p2.project_id prevents duplicate pairs and self-matching. Next is salary ranking system. So no gaps in ranking sequence if two employees tie for second place. The next rank is third. So highest salary gets rank 1, ensuring intuitive top-down ranking system. Select EMP underscore name salary dense underscore rank over into bracket order by salary desk as a salary underscore rank from employee. Next is palindrome name detection. So this query works in database supporting the reverse function like SQL Server and MySQL. A palindrome reads the same forward and backwards. This query identifies employees whose names have with unique property. So select EMP underscore name from employee where EMP underscore name is equal to reverse of EMP underscore name. Right? For case insensitive matching, wrap both sides with upper or lower function. Now third highest salary by the department, and you can get your query on your screen. Strategy value helps identify mid-tier compensation levels across different departments for benchmarking purpose. Please write these queries in your SQL editor. Next is peak individual contribution. This query identifies the employees who logged the highest number of hours on any single project, revealing peak individual contribution. So finds the absolute highest hours worked across all employee project combination. Identifies top performers and potential workload distribution issue. Query in your right section. Next is high performing team leaders, managers with the high salary teams. So this query is a little bit small, so I will explain. Select m.emp name as manager, average of e.salary as avg underscore team underscore salary from employees. M join employees E on m.empid is equal to e.manager id group by m.emp name having average e.salary greater than 65,000. So identifies managers who successfully lead highest value teams indicating strong leadership and talent development capabilities. Next is organizational hierarchy mapping. This query creates a comprehensive view of the organizational reporting structure showing every employee alongside their direct manager. Select e.emp underscore name as employee, m.emp underscore name as manager from employee E, left join employee M on e.manager id is equal to m.employee id. The left join ensures executive with null manager id still appear with null manager names. Now, departments with 100% employee engagement. This advanced query uses double negation, not exist within not exist, to find department where every single employee has worked on at least one project. The query is on your screen. Please write these queries on your editor. Now, subordinates networking supervisor may indicate exceptional employee dedication or potential management delegation issues. The query is on your screen. The query is little bit lengthy. Please write this query in your editor. And the 50th question, pivot table for hours by role. The final query demonstrates advanced pivot table functionality using case when statements to transform row data into columnar analysis. It provides comprehensive resource allocation analysis across different roles, enabling better project planning and budget forecasting. The query is on your screen. Please write this type of query in your editor. If you have created all 4 tables which I have mentioned in the starting of this video. Now, let's move the most important concept again, the SQL stored procedure. Master the fundamentals with 5 essential question and answer examples. Learn how to create, execute and optimize stored procedures for efficient database operations. These practical examples will prepare you for a real world SQL development scenarios. The first stored procedure is write a procedure to increase salary of all employees in a department by 10%. So, delimiter with symbol, create procedure, increase salary. The in parameter is department ID, data type is integer. Begin, update employee set salary is equal to salary into 1.10 where department ID is DPT ID. Then end and your end of delimiters. The delimiter usage for the procedure definition, in parameter for the department ID, mathematical operations in update where close for targeted updates. Next is create a procedure to fetch all employees working in a given project, and procedure is on your screen. So please write this procedure and definitely will fetch all employees working in a given project. This procedure demonstrates the power of join operations within stored procedures. It connects the employees table with employee underscore project junction table to retrieve specific project team members efficiently. Third is procedure to return total salary expense of a department. So financial analysis made simple, calculate departmental cost instantly with this aggregate function procedure. It enables quick budget analysis and cost center reporting for the management decision. And stored procedure is on your screen right side. Now, fourth one is write a procedure to insert a new employee record. This is one of the important, and the stored procedure is on your screen. This procedure showcases multiple parameter handling and proper data type specification for comprehensive employee onboarding automation. And the last stored procedure is procedure to list employees who earn more than a given amount, and the very simple stored procedure is on your screen. So this is the top most 5 procedures which will help you definitely to boost your SQL, advanced SQL concept. Next is SQL triggers. Automate database operation with 5 essential trigger example. Triggers fire automatically in response to database events like insert, update or delete operation. It enforces business rules and maintain data consistency across related tables without manual intervention. Create comprehensive logging systems to track changes and maintain historical records automatically. So the first trigger is create a trigger to log every new employee insertion, and here audit table setup is already given and you can create a trigger implementation on your right side screen. So please create this table and then after implement this trigger. The log table captures essential audit information with automatic time stamping. You can pause this video and write this query. You will definitely get your better output. Next trigger is trigger to prevent salary from being set below 30,000. Right? And here you find a perfect way to create a trigger. So this will definitely help you to boosting your trigger knowledge. Third one is trigger to update department's total employee count. So first of all, you will have to create a count table and then after auto update trigger will be there. This pattern demonstrates denormalization for the performance. Maintaining aggregate counts in real time to avoid expensive count queries during reporting. The fourth one is trigger to prevent deletion of managers. So to prevent orphaned employees records by blocking managers deletion when subordinate exist. So this is your trigger. Please create this trigger. Next one is trigger to automatically assign default project when employee is hired. This trigger is one of the most important trigger in the most companies interview questions. This question is asked. Next is now cursor. So 5 cursor example is here. So first is cursor to display all employee names one by one. This cursor will help you to display all the employee names one by one. Please create this cursor and execute this. Next is cursor to give 5% salary hike to each employee. Right? All setup is on your screen. You just have to write this whole query and execute once. Third one is cursor to calculate total salary of all employees. Fourth one is cursor to copy employees into a backup table. And this is one of the most important cursor. And the fifth one is cursor to list employees hired after 2018. So you are now ready for SQL interviews. You learn 15 most important SQL questions covering stored procedure, trigger and cursor. Hands-on experience with real-world database scenarios that appear in SQL developer and analyst jobs. Practice these examples to crack technical interviews with confidence and demonstrate expertise. Practice on real database. Watch again and practice queries on actual database systems to reinforce your learning. Explore Java and Python interview playlist on this channel for full stack development preparation. Like, share, subscribe for more high quality technical content and interview preparation. Your SQL interview success starts here. Keep participating, keep practicing. Thank you very much guys for joining with me for this amazing 65 SQL questions. Thank you very much guys.